Hello everyone, welcome once again to Slidescope. Today we are discussing roadmap to become a deep learning engineer. So if you are planning to become a deep learning engineer, this roadmap will help you in getting started, or if you have already completed some steps, then you will know what is the next step you can take in this particular journey. So, my name is Ankit Srivastav, and over past 12 years, I have worked extensively across digital marketing, analytics, IT training, and full stack development. But one area that excites me the most is artificial intelligence, particularly deep learning. As someone who has trained thousands of professionals and students in data analytics, machine learning, and emerging technologies, I often get asked, Ankit, what's the right roadmap to become a deep learning engineer? This question makes sense because deep learning engineers are among the most in demand professionals in AI era. They are the mind behind facial recognition system, autonomous cars, speech assistants like Alexa, generative models like GPT, and breakthrough medical diagnostic tools. In this article, I will walk you step by step through the roadmap to becoming a deep learning engineer, sharing not just the technical skills you need, but also how you think like a problem solver and prepare for long term success in the field. First task is understanding the role of a deep learning engineer. Before we dive into skills and tools, it's important to understand what a deep learning engineer does. A deep learning engineer is responsible for designing, building, and optimizing deep neural networks, working with massive data set, structured and unstructured, and applying computer vision, NLP, or speech recognition techniques, experimenting with architectures like CNN, RNN, LSTMs, and GANs and transformers, collaborating with data scientists, ML engineers, and domain experts. Unlike a machine learning engineer who works broadly on algorithms, a deep learning engineer focuses heavily on neural network based approaches and solving problems via where classical ML falls short. So in classical ML, we have supervised and unsupervised machine learning. Obviously, it is there, but there the algorithms are different. They are for small data sets particularly, but here when they fall short, then comes neural network based approaches. Second is build a strong mathematical foundation. I cannot stress this enough. Math is the language of deep learning. Every neural network activation function and optimization technique is grounded in mathematics. Here are the areas I recommend mastering. Learn linear algebra, vectors, matrices, eigenvalues, eigenvectors essential for CNNs and embeddings. Then calculus, differentiation, gradients, and backpropagation are calculus heavy. Probability and statistics, distributions, Bayes theorem, and statistical interference or inference, sorry. Optimization like gradient descent, convex optimization, and learning rate scheduling. Resources I will suggest are given here. I will provide this link and you can refer to them. Third is become proficient in programming. Programming is the tool that brings deep learning model to life. From my experience, the following languages and tools are most relevant. First is Python. This is the first choice for deep learning due to its simplicity and vast ecosystem. Libraries like NumPy, Pandas, Matplotlib, TensorFlow, and PyTorch are Python based. You can also learn R, that is more statistical but useful for exploratory data analysis. If you have knowledge of C++ or CUDA for optimization and working on GPU level customizations, that will also be good. And SQL for querying data sets from databases. Many times you will get your data set will be directly from a SQL file. So if you know SQL queries, that is always good. Tip from my journey, you can start with Python, master it, then branch out into GPU programming with CUDA. If you are serious about research, or performance optimization. Fourth is learn data pre-processing and feature engineering. So this will be your fourth stage. Data pre-processing, that is, data is rarely clean. A deep learning engineer spends a significant portion of time preparing it. Data cleaning, that is handling missing values, outliers and anomalies. On our channel, you will find many videos related to data cleaning, but if you want to do it with the help of pandas, we have a specific pandas playlist where you can find out 20 videos that will help you in getting started with these kind of tasks, that is data cleaning, normalization and standardization, that is scaling input features to help network converge faster, data augmentation, especially in computer vision where rotations, flip or cropping is needed. Then feature engineering. Through deep learning, though deep learning automates feature extraction, you must understand domain specific features. Tools, pandas, numpy, scikit-learn and opencv if you are into image processing. We have some videos like object image classification project with CNN in Python, and we have similar projects and approximately 17 machine learning tutorials also on our channel itself, where you will find a lot of this to get started. After this you can master core deep learning concept. This is the heart of roadmap, starting by building a strong understanding of how ANNs work, that is artificial neural networks work. Topics are, you can see perceptron and multi-layer perceptron, that is MLP, activation functions, that is ReLU, sigmoid, tanh, softmax. In these videos you will find many videos related to ReLU and sigmoid. Then forward and back propagation. Then you have loss functions, that is cross entropy, MSE, hinge, and optimization algorithms like SGD, ADAM or RMSP, ROP or RMSPROP. Once you are comfortable with ANNs, move to advanced architectures like CNNs, that is used in computer vision tasks like image classification, object detection, that you can see here, and facial recognition. Recurrent neural networks, RNNs, that is sequential data modeling. You can learn LSTMs and GRUs for long-term dependencies. Then you have transformers, revolutionize NLP, that is BERT, GPT, T5, etc. Also increasingly used in vision, that is VIT. Then you can go to generative models, that is GANs, and variational autoencoders, that are VAEs. Recommendation is start implementing simple models in TensorFlow, Keras or PyTorch. Then theory plus hands-on equal to mastery. Understand deep learning frameworks. A deep learning engineer must be comfortable with at least one major framework. You can either go with TensorFlow plus Keras. This is a beginner friendly, production ready, widely used in industry. Then you can also choose PyTorch, that is preferred for research, flexibility and ease of experimentation, or MXNet or JAX, that is useful alternative though less mainstream. Practical advice will be begin with TensorFlow and Keras. Many such videos are already there on our channel and many other channels on YouTube. Then you can work with big data and cloud platforms. Deep learning often requires handling huge data sets. That's why cloud skills are invaluable. Data handling, that is Hadoop, then Apache Spark or Dask. Cloud ML services such as AWS SageMaker, GCP AI platform or Azure ML. This is also good. We have been trying this recently. Data pipelines like Airflow, MLflow or Uberflow. Pro tips: cloud certifications in AWS, GCP can boost your profile when applying to AI-driven companies. Eighth step is then you can build practical projects. Theory without practice won't make you a deep learning engineer. You must apply your knowledge to real world projects. Some project ideas I often give to my learners are computer vision, that is hand written digit recognition, that is MNIST, then real time object detection, that is YOLO or faster RCNN, NLP, where you can do sentiment analysis on Twitter. If you are if you are a fan of sitcoms, we also did Friends sitcom dialogues, sentiment analysis. Then we have 6 videos for NLP, mastering NLP. So these will obviously these will not make you you know deep learning engineer, but obviously whatever steps are written, they will help you because you have a lot to capture, and the time frame is also very big. It will take you at least 8 to 10 months to master all this. So then you have speech recognition. Building a voice assistant can be a project that you can do for speech recognition, and generative models like creating new images using GANs. So we are working on this and it will be uploaded very soon. Document your projects on GitHub or Kaggle. This is very important because this will help you in showing your projects. You can also mention them on your LinkedIn profile. So you can share your LinkedIn profile, your GitHub profile, your Kaggle profile, and when it when recruiters will see that, they will definitely love that. Research and continuous learning. Deep learning evolves daily. As a scientist engineer hybrid role, you need to read papers, AR, XIV, Google Scholar, and other sources are there. Stay updated with conferences, that is NeurIPS, ICML, CVPR, etc. Experiment with new architectures. Personally, I recommend the Illustrated Transformer blog series. You can check them out as well. Master model evaluation and optimization. Building a model is just half the job. Improving it is the other half. Metrics are accuracy, precision, recall, F1, ROC, AUC, Blue for NLP. Then regularization, dropout, L1, L2 penalties. Obviously, when you will learn them, you know these terms. Now you have to learn them. Then hyperparameter tuning like grid search, random search, Bayesian optimization, etc. And then you have model compression, that is quantization, pruning for edge deployment. Next, you can build domain knowledge. One of the biggest differentiators I have noticed in successful engineers is domain expertise. For example, in healthcare, understanding medical imaging; in finance, knowing knowledge of fraud detection and stock data; in NLP, linguistic and semantic. If you have this kind of domain knowledge or this kind of domain knowledge, then you will be able to create models for them. You will be able to create solutions for them in an efficient way. So pick one industry or domain and specialize after you have mastered the basics. Next is soft skills and problem solving. Technical skills make you capable, but soft skills make you valuable. Critical thinking is something like define the problem before choosing the algorithm. Then we have communication, explain model results to non-technical stakeholders, and collaboration, work with cross-functional teams, data engineers, product managers, etc. Next, we have career path and growth. So entry level, you can go with data analyst, junior ML engineer. In mid level, you can do deep learning engineer or applied scientist. And for advanced, you can do AI research, become an AI research scientist, AI specialist, chief AI officer. Salaries for deep learning engineers are among the highest in AI field, often surpassing traditional software engineering roles. Then we have learning resources. I will give these links to you in description. And obviously you have our channel. You can join if you want to start your career in deep learning and artificial intelligence with hands-on projects, real-world mentoring, and structured training. You can join our AI and deep learning course at Slidescope as well. It will give you great start. We will teach everything from scratch, and you will be able to create efficient models. So start with first step, or if you have already taken some step, you can follow this roadmap. If you have any questions, you can ask them in the comment section below. We are creating this roadmap series where we will bring more and more videos. So please subscribe to our channel so that whenever we'll upload one more video, you will get notification. Thanks for watching this one. Have a nice day.